Hello, my name is Rico Tyler and I'm with the National STEM Scholars Program. I'm going to share with you today another way to bring more phenomena-based science, more sense-making, and more claim evidence reasoning into your classroom. Today, we're going to look at two different next generation science standards in 7th grade. The first one, which is PS3-5, deals with construct, use, and present arguments to support the claim that when the kinetic energy of an object changes, energy is being transformed to or from that object. In addition to that, we're looking at another standard, PS2-33, which is applying scientific principles to design, construct, and test a device that either minimizes or maximizes thermal energy. Now, in this activity we're going to do today, that second standard, we're kind of sliding it into the side because we're really converting thermal energy into kinetic energy. This activity is also going to deal with all four of the engineering standards for middle grades: defining criteria and constraints, systematic evaluation of different solutions, analyzing data, and iterative testing, similar to some other things that you've seen us do here. The materials for this are very simple. We're going to need some aluminum foil. A couple of sheets of that would be just fine. We're going to need candles. These are little tea candles that work just fine for this activity, although a little later on you're going to see me use a different candle, a nicer candle. You're also going to need some scissors. A binder clip is very helpful here. And you're going to need some kind of pointy tall item. A bamboo skewer works perfectly for this purpose, although that might not be something you happen to have in large quantities in your classroom, although they're very cheap at a store. A pencil works in this activity very well. And you're going to need some matches that goes along with the candle. What we're going to do here is design and build something called a candle turbine. A candle turbine is a device that turns the heat of a candle into motion. Now let me show you how you make one of these candle turbines. You start with some aluminum foil. Now you can do this activity with cardstock or with paper, but I don't like personally the combination of paper and an open candle flame, so aluminum foil is my preferred way to go. You take a small piece, and you can tell I just cut this piece because it's yay big by yay big. Size is not critical, but this is about how much you need. And what I'm going to do is cut a spiral out of it. Now I have to warn my viewers that I am terrible at this, but fortunately I don't have to have a lot of skill at it. The exact size kind of depends upon the setup that you're using. And we talk about this a little later on. We're going to talk a little bit more about what you can do with this. But about a 4x4 inch square of aluminum foil is plenty big enough for this. And your spiral is going to have good spots and bad spots, but this is a pretty tolerant activity. And there. And put that back together. And what you've got is a spiral. And what you're going to do with the spiral, you're going to hold it like this, and you're going to make a little cup here at the top so that you could hold it, something like that. Now, I can play with this one, or just like in a cooking show, you can use one that you've already cut. And I've cut this one, made sure it worked in advance. Now once you have this done, you're going to then take your skewer, or you're going to take your pencil, and you're going to attach it to a binder clip, like so. Now you've got a little stand that you can move around. And now you're going to take this spiral, and you're going to put it here. Now what I did here at the very top is make kind of a little cup with the remaining aluminum foil so that this can spin. And my spiral, I want to look and make sure it drops down, and you can see here just Blowing on it makes it turn, which is a good thing. I don't mess up my turbine. So what we have made here is most of a turbine. This device we want to spin using heat energy, and we need a source of that heat energy, and that source is going to be a candle. So I'm going to bring it right here and watch it start. It's kind of fascinating to watch one of these go. But what you're looking at here is a classic example of energy transference. The wax inside this candle is a source of energy. It's chemical energy. And when I light the wick, then I'm taking that energy and utilizing it. I'm burning the fuel, the wax, and the work that's done by that burning creates heat. So invisible, but right in here, is that hot air that's rising from the candle. So I've converted energy in the form of chemical potential energy into heat energy. As that rising air strikes the turbine, it spins the turbine. So the heat energy is doing work to spin the turbine, and therefore the turbine gains kinetic energy. Now, this is a small little machine here, but in principle, we could utilize this rotation to turn a generator, to generate even electricity, although we're on a little bit too small a scale to do that practically. So now we have a demonstration that shows that, and we can do things with it. Ideally, what we want to do is maximize the conversion of heat energy into this kinetic energy. And by the way, we really can't do an experiment. We really can't study this unless we can quantitatively look at it. And everything we've got right here is very qualitative. But look at the turbine blades themselves. I can actually time them. 1, 2, 3, 4, 5. I could, for example, time the number of rotations in 10 seconds, which is exactly what I'm going to recommend that you do, and actually figure out the speed of this turbine in rotations per second. If I can make this rotate faster, I'm getting more of the heat energy to become kinetic energy. So I can now play and modify with this device. What if I change the angle? For the same piece of aluminum foil, what if I had lots of spirals cut or very few? Is this the right mass? Maybe I could adjust the mass. I could have my student teams studying this phenomenon and then judging how successful their changes have been by how quickly the candle turbine rotates. So I've got all sorts of possibilities here for them to practice engineering standards and engineering skills, and to look at quantitatively the transformation of heat energy into kinetic energy. I could even give them, for example, a fixed amount of aluminum foil. This piece is less than half a gram. I could give them a standard amount of it. I could even take the speed of this blade in rotations per second and divide it by the mass. So a turbine blade spinning at this same speed but smaller, lighter, would be more efficient. And it gives me a way to judge. And that's the key here when you're using a phenomenon. You want students to be able to manipulate the device or the experiment to get a certain result. That's how they're learning those science engineering skills. It's also how they come to grips with this concept. Energy, heat, the transformation of energy, these are all very abstract ideas. And anything that's concrete will help your students have a better grasp of the concept. Now, along with this, we've got an open flame here. So there are some safety concerns. I mentioned earlier about the use of aluminum foil. You could easily make this turbine with paper, but you've got paper in the association with the candle. I also like to keep around just a spray bottle of water. I always like to label my spray bottles. This is water, not something else. So if I had a little accident, I could just spiff it off. And so having a few of these around is not a bad idea. Using the stand that you have right here lets you move the candle away before students start playing with this. So they'll want to adjust this and they can bring the candle back in. You can even get rid of the candle. We're using a candle because a candle, whether one of these or a tea candle, is an easy source of heat. But you can also do this with a light bulb. Not with an LED light bulb or not with a fluorescent light bulb, but if you have an ordinary 60-watt incandescent bulb, it generates easily enough heat to turn this turbine. And so I've actually done that just using a small lamp as my source of heat. And I can do the exact same experiment and simply avoid using fire at all. But the key here is this gives your students a way of looking at the transformation of energy, in this case from heat to kinetic, and do it in a quantitative way with actual experimentation. I think you'll find this to be an engaging activity for your students and a great phenomenon that you can bring into your classroom. As always, thanks for watching.